Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudi. This lesson is brought to you by the Gauteng Department of Education in collaboration with Bono Discovery Center. Now, today we're going to look at paper 1 revision and some of the tips that you need for your paper 1 tomorrow, the 31st. One of the things that we really need to look at is what we need when we go into that examination. Now, the exam stationery that you need, remember in grade 12, you need your transparent plastic pocket, wherein you would need to have your ID book or ID card, and also you need to have your examination timetable. You also need the calculator within your battery. I know you've been using this calculator for the better part of the year, and some of you have been using this calculator for 3 years or so. Please check that the batteries are still working there. You need a blue pen and an extra pen. Remember, we use blue pen, don't use the black. You need a pencil. You need an eraser. And you need a ruler. So those are some of the things that you need for your stationery that you need for the exam. Now, paper 1 topics and weightings of content areas. So I've just put those topics in there, and also the marks, the marks for those topics. Now the first one there is algebra, which is plus minus 50 marks, which is a lot of marks in algebra. And remember, algebra, most the things in algebra, they form the core of what you need to use in some of the topics like functions and differential calculus. So if you understand your factorization, you understand your simplification, then obviously your functions will be much easier. If you understand your exponents, your differential calculus will be much easier also, and the integration. We have finance there also, which is plus minus 15 marks. We have the calculus, which is plus minus 50 marks with integration there. So the functions plus minus 35 marks. So please make sure that you know the weightings of those topics so that you don't go home and practice financial math for 2 days. Or I mean for 2 hours or 3 hours, and then you're going to get 15 marks for this. Okay, right. The formula sheet is very, very important. So when you're practicing today, take your formula sheet, put it aside, know each and every formula there, what it is used for. But please do not memorize the formula. Just know which formula is used for. So all those formulas, you can break them down in this way, that you have got your algebra and your functions and graphs formulae, mostly the formulas that you're going to be using there. You have your finance, the growth and decay, those are the most formulas that you're going to be using there. Differential calculus, integration formula, then you know exactly that these are the formulas that I'm going to use. Where do I use this formula? Where do I use that formula? Okay, right, I'm not going to go through that formula. Now look at the algebra. We're going to start with the algebra. So look at this algebra. First, the quadratic equation in algebra. Write down the equations in standard form. In other words, in algebra, when you have the equations, the first thing that you need to do is to write them down in standard form. And your standard form is ax squared plus bx plus c. Don't forget the equals to 0. Then you do that before you factorize or you want to solve. Okay, so if I look at this question here, the first one there, that question there, it's not in standard form. So for me to factorize that or to solve that, I need to write it in standard form. So how do I then write it in standard form? Remember, in standard form, it means that my right hand side must always be equals to 0. But if I take that minus 4x to the left, I'll get plus 4x. So, but I need to know where to put it, and the 15 is not in its right place in terms of the standard form. So I must first write it in standard form. if I look at this one, it's already equals to 0 and we already have vectors. So there's no need for me to factorize this. So I'm not going to factorize, it's already factorized. If I look at that one, the one is equals to 0, so it is in standard form, but it's not yet factorized. So this one is already factorized, but this one is not factorized. That one is not factorized, so we cannot be able to solve those two because they're not factorized. With the middle one, I don't need to multiply out. Please do not multiply out that, because if you multiply it out, it means that you need to factorize it again, so it'll come back to the same answers. Right, now let's look at the first one. If I look at the first one, to write it in standard form, so what do I start with? I start with the x squared, so I'll have 4x squared. Then the minus 4x comes this side, it becomes plus 4x. And we have the 15, which is still on this side, which is a positive, so it will be plus 15. Must not forget to put equals to 0 because it's an equation. Now, how will I solve this? I can see, if you don't know how to factorize, please use a quadratic formula. But I can see this one cannot be factorized. I'm trying to get the factors of 15 that can give me and the factors of 4 that can give me 4, and I can't think of any. Now, look at what is happening here now. We're saying you must also be able to apply complex numbers in cases where the roots are non-real. Very, very, very important. But I know in the question paper they will write your answers as complex numbers. Okay? It's a complex answer. So in this case, I can see, let me use a quadratic formula. If I use a quadratic formula, I'm not going to do the whole sum, but I just want to show you one. Okay. Remember quadratic formula, minus b, so it will be my minus 4 plus minus the square root of the 4 will be positive squared. So now it will be 4 multiplied by, so what I have in the bracket is the 4 for A and 15 for C. Then divided by 2 times 4, which is 8. So if I look at this and I use my calculator, I'll get minus 4 plus minus the square root of 16 minus, that's 60, and 60 multiplied by 4, that will be 16 by the way. So it will be 16 minus, so I'll have 4 times 15 is 60. And 60 multiplied by 4 is 240. So I can see there am I going to have a negative answer. Then I can use my knowledge of. So if I go to my calculator and say 16 minus 240, and the answer that I'm going to get is 224, which is a negative all over 8. Then I can use my knowledge of complex numbers. I know that the square root of negative 224, I can use the I there. So just to quickly work that one out on this side. So if I use my I there, I'm going to have minus 4 plus minus the square root of 14, and then there's an I. Because the square root of, it will be 2 square root of 14i all over 8. So I can be able to do that. So I know the square root of 224. I go to my calculator and get the square root of 224. Then I get my answer as 4 root 14. Then I can be able to write it as a complex value. I'm not going to finish that. To do that question, I know you can be able to do that. So please guard against that. If I've got a negative, then I go for complex. Okay, so I go for complex. If I have a negative inside the square root, and this is what you do under complex numbers, and then you know that number you need to write this a negative. Now in this question here, the 7 minus 2x, already that is factorized. So I just need to get to 7 minus 2x is equals to 0, or 7 minus x equals to 0. then obviously my x value will be equals to, so if I take the 7 that side, it becomes a -7. Then I'm dividing it by -2. My x will be 7/2. Or if I take the x to the other side, I'll have x equals to 7. So these are my final answers. So you can see, quite easy to do this type of question. Already I know that this standard form, I cannot put that one in standard form. It's already in standard form, so I just need to work it out. Now with this one, it's already in standard form. I need to factorize. So to factorize this, remember I must first divide by 3, everything there by 3. So if I divide by 3 there, I get a 1. If I divide by 3 there, I get a 9. And then from there, I can factorize this. This is quite easy to factorize. X minus 3, x plus 3. And then my x value will be equals to 3. Or my x value is -3. And that will be my final answer. Okay. So the only part that you need to understand here is that if I use a factor, if I use factors, if I use a formula, then I get a negative. Then if the answer says, if the question says, write your answer as complex numbers, then you're going to go and do the I part. But if the question is just solve for x and they leave it like that, so what do we need? Like in this case, I need to stop it there, and then I can just write down my answers are non-real answers. Remember, they are complex numbers and non-real. Complex is imaginary. Those are terms that we use when we have a negative inside the square root. Okay. Now let's jump to then the inequality. So you'll have your algebra where the first question there will be solve for x. The next one will be solve for x correct to 2 decimal places, where you need to also use a calculator there. Then the next one will be this type of questions where you are applying factorization method as in equations, but finding the critical values and getting the right values. Now, first of all, here I need to get the critical values. But before I get the critical values, that's the first thing that I'm going to do is, now if I take this one, x into 6 minus x, I just want to write this x minus x. That makes my life easier. So I can take out negative as a common factor. Please do not divide throughout. And then from there, I can write this one as x minus 6. Then I can put greater or equals to 0. This is going to make my life very easy. So if I take out negative as a common factor, these two will solve. The x and the signs will change. The x will be a negative. If I multiply the negative inside, the x becomes negative. The 6 becomes a positive. So now from there, I can then divide throughout by -1. Then I'll get x into x minus 6. Then that sign must change to a less than. So if I divide by -1, the inequality sign will always change to a different sign. So once I have this, then I have my critical values. So I'm going to write CV there, which indicates my critical values. My critical values will be my critical values will be a 0, and the other critical value will be a 6. How do I get that? X equals to 0 and x minus 6 equals to 0. These are critical values, they are not answers. So x minus 6 equals to 0. So the x will be equals to a 6. So once I've done my critical values, what do? I need a solution. So now I'm going to draw a number line. Then I have x equals to 0. I have x equals to 6 here. So that's my number line. Now I need the values where the whole inequality will be less than 0. So remember, I'm now working on this part. So it must be less than 0. So where is it less than 0? It will be between, so I'm looking at this. So it will be between this and that. So it will be between 0 and 6. It's like drawing a parabola graph. Where is the parabola graph? Below the x-axis. It must be between 0 and 6. So if I know it's less than, so less than, I know my answer will be in between right? If it's greater than, it will be away. So in other words, now in this case, it's less than, so it must be in between the two values. In between the two values. So I'm going to write my answer. I write x in the middle, the 6 on my right, the 0 on my left, and I just write less and less. And that's all that I do. So that's my final solution now. Please don't leave your answer on the number line. Just write down the answer there, so that, because then remember, sometimes they will say solve for x in that way. The other question will be solve for x and show graphically your final answer. So in other words, if I've got a number line, it will be graphically. But if it just say solve for x, I just put it like that. Don't leave it as a graph. Now, the same principle will apply here. This is less than also, it means that my answers will be in between. So meaning that I must first get my critical values. First, I must factorize that. In this case, I'm not dividing anything by -0. I mean, sorry, by -1. So my critical value. So please, let's write it like this. Don't write x is equals to. Because once you write x equals to 0 and x equals to -1, you are not writing critical values. So you are writing your answers as the value of x, because the question says solve for x, and you are writing x equals to 0. Unless if you continue there. So you write CV critical values, which is your 0 and -1. Why do we need to write the critical values? So that we are able to can come here and draw our nice number line. So with our number line, we have a 0 there. Okay, we have got a -1 there, sorry. And then we might have a 0 somewhere there. So we're saying the graph is less than. So less than means in between. So when the values are in between, it means that in this case, it will be like this. Now I want you to look at the difference between the two. In this one, I've shaded the dots. In this one, I did not shade the dots. So which means if I've got greater or, less or equals to, then the dots must be shaded. If I've got less than without an equal sign, those are not shaded. Okay, those many circles are not shaded. So my answer will be x will also be the one on the right, I put it there. The one on the left, I put it there. I just put less than or less than. In this one, I put less or equals to, because the question was on less or equals to. This one is less than, because the question was less than. The inequalities are not very challenging. You must be able to can get there. Once you know that, if we say away, it means that we are talking from 6 away, from 0 away, so that will be away. So you're writing x is greater than 6, x is less than 0. That's when the equation, the inequality is greater than. So greater than means away from those values. Okay. All right. Now, simultaneous equation, I know most of you guys, I don't know why, but most of the learners, when you go to schools and you're doing the algebra, they say, please do the simultaneous equation. We're having a problem with simultaneous equation. I don't know what the problem is there, but pay attention now. Now, I'm solving for x and y. In simultaneous equation, you're going to have one equation which is linear. You're going to have one equation which is a quadratic. You're going to then try to substitute the solved value into the linear equation. Then from there, remember, you're solving how many? Two unknowns. How many unknowns there? Two, because we've got x and y. Now, the reason for us to begin two equations is that it must be easy for us to solve the two simultaneously. So the x plus y is one of the equation will be the easier one equation. In this case, x plus y is an easier equation. So what do I do here? I come here and I can make y the subject of the formula. Then I'm going to get 4 minus x. I'm going to call this one equation 1. I'm calling that equation 2. Now, once I've done that, I'm going to call this one equation number 3. So if you understand the word substitute, you know, when we substitute, we are taking this out, we are putting something in. That's where the problem lies. Equation number 3, it's not a problem. Most of you get this equation number 3 even when you're marking at the end of the year. We know you get that equation 3, but then substituting is the problem. So which means wherever I'm going to see a y in this equation, I don't need that y, because the y now must be represented by 4 minus x. Once you get that right, then the simplification of that becomes easy. So which means when I come to this equation, the x squared I'm going to keep, minus 3x I'm going to keep. What I don't want is the y. Okay. Plus, what I don't want here is the y. And that equals to 8. So what I did was just to replace the value of y. So this thing is still y. So if I read it again, it will be x squared minus 3xy plus y squared, it's equals to 8. So I'm just replacing this little thing here by what I already said, y is equals to. Then the simplification becomes quite easy now. I know you can simplify. Everybody can simplify. We are multiplying out here, we're getting 12x. Multiplying out that negative and negative gives us a plus 3x squared. That we are multiplying out, then we're going to get 16. 4 times x is 4x. Double that, we get minus 8x. Then we get plus x squared. I'm bringing over the 8, which is 0. Okay, so now I'm now going to add like terms. So I'm going to get x squared, 3x squared plus x squared. So I'm going to get 5 of them. Now maybe minus 12x minus 8x. Then I'm going to get minus 20x. Then I've got a 16 minus a 8. So if you are having such things, then you can use color. Then you color the ones that are like terms, and then from there it's easier for you not to miss the other when you are adding. So this 20x, we said 16 minus 8, and that will give us a plus 8, and that equals to 0. Now once I have this, so I'm going to now I can see there I need to use a quadratic formula. So I can use a quadratic formula, which will give me minus 20, which is 20, plus minus the square root of 20 squared, which is 400, minus 4 into 5 into 8, all divided by 2 into 5, which is 10. So I think the x values that I got there was 3,54. The other one was 0,45. Right. So my x values I have. Remember, I don't stop there because I only got the x values. What do I need? I need the y values. So how am I going to get the y values? I'm going there. You see. Then I say my y was equals to 4 minus. The first value of x is 3,54. Or the other value of x was 4 minus 0,4. So I'm going to say y equals to, use a calculator, and my calculator there will give me 0,46. If I use my calculator there, I'll get y is equals to 3,55. And that is simultaneous. So I've solved for x and y simultaneously. So I've started with the x. How did I start with the x? By eliminating the y, so that I'm left with the x only, and then I can solve for x. How do I get the y values? By taking my x values, substituting them into the original, or into the equation number 3. So that will be an easy equation to work with. Okay, right. So simultaneous is quite easy. Very easy. You're going to get simultaneous equations in graphs. You know, you're going to get it in a lot of places you get simultaneous equation. So for instance, in the graphs, if I've got a graph like this, and this graph, the parabola graph is drawn, and I've got a straight line, and it passes through this point and that point, and from there they say solve for x and y simultaneously. So it means that I'm going to get my straight line graph, which might be y equals to mx plus c, and then I'm going to get my parabola equation. Then I can be able to quickly solve by taking the straight line, the equation of the straight line, creating equation number 3, substituting into the parabola graph, then from there getting the equation that I can solve, and then I can then go back and substitute those values to get the y value. So you'll get simultaneous equation in graphs also. The real life technical problems whereby you have that story, and then mostly we skip that question because we're thinking, how am I going to solve such a problem with a lot of weight there? The wheel balancing machine is rotating at the rotational velocity v in meters per second. The formula for the rotational velocity is given there. But what in that question, what they basically want to ask you is just to make something the subject of the formula. Okay, that's all. And then from there, and substituting the values, use a calculator and get to the final answer. That's what they're asking you. So in this case, look at this. Express R as the subject of the formula. It's got nothing to do with the rotational velocity. It's got nothing to do with the wheel balancing machine. You are just taking the formula and making R the subject of the formula. Right. So if I've got V equals to 2 pi R all over T, I know V is equals to 1. Then I need to make R the subject of the formula. First, I need to cross multiply. Then I'm going to get VT. V times T equals to 2 pi R. I need to separate the R from the rest of the stuff there. So to separate R, I need to divide by 2 pi, divide by 2 pi, and 2 pi cancels 2 pi. Therefore, my answer is going to be R is equals to VT over 2 pi. That's all that they want you to do. Okay. In that question, when I was doing that question, I never talked about rotational velocity, never talked about meters per second, I never talked about that. Okay. All right. Now, in this case, you are given that the velocity now, that velocity now is given as 91.116 kilometers per hour. Right. So that should be meters per hour. Yeah. That should be meters per hour. Meters per second. Sorry, meters per second. That should be meters per second. Okay, because I've already worked it out. It was kilometers. The question was kilometers, but I've already worked it out to 91.11. Okay, so that should be meters per second. All right, let's work it on meters per second. So now the velocity has been given. Now it's meters per second, 91.116 meters per second. Now they want us to calculate the value of R. Obviously, the formula is already there. Then what I need to do is just to substitute. The velocity is 91.116 meters per second. And we are multiplying with the time in seconds, which is 1.94 times 10 that. And we're dividing this one by 2 pi. Okay. So now you just take out your calculator and work it out. Obviously, the answer will be in meters. Remember, because the second meters per second, we are multiplying by seconds that are for the time. So the S and the S cancels out. I'm left with the meters, and the answer that I'm going to get, they say it in scientific form. So it's 81 multiplied by 10 to the power negative. So you are able to then see that it is nothing, this question has nothing to do with my rotational velocity and all that. I don't need to get any other formula. The formula is given, just manipulate the formula, substitute from the formula, and that question is always there in your question paper. Okay, right. We are still in algebra. Can you see how much work you need in algebra? You need a lot. So now, if I look at this type of questions, I'm not going to also waste time on this one. It's the logarithms. One of the things that you need to go and do with logarithms is to go, and exponents is to go and learn your rules and laws of exponents and also of the logs. The log of a negative number. I know in this one, most of you are going to use a calculator and then you're going to get an undefined situation. So in this case, in this question, the log of a negative number is undefined. All right, so they just needed the part to say, I cannot define that part because the log of a negative number is undefined. The trick here on the second one, it's most of you, when you see a 0, you just write 1. Anything raised to the power 0, you just write 1. But you don't see that the 0 is only for the bracket. So in other words, it is 3 multiplied by. So it's 3 multiplied by 2x all raised to the power of 0. That's what it means. So the one that is raised to the power of 0 is 2x. So it is 3 multiplied by 1, which is going to be a 3. So the answer there will be 3. Okay, so take note of that. These are simple marks that you must get in the exam, and then we mess up big time with this type of question. Now with this one, it's basically your log equations are quite easy. I mean, first of all, I must get this one right. The log of 100 is 2. So I must get a 2 there. And I'm getting the log of 2x base 3 equals to the log of that. Now, what is the first thing that I'm going to look for here? I'm looking at the bases. The bases are the same. So which means I can then take this one to the right hand side, to the left hand side, right? And then I subtract it because it's positive. Then I put that equals to 2. Then because there's a negative, remember laws of the logs says if the two logs are subtracting, then we divide their numbers. So this is their number, that is their number, which means I write them as one log and divide them all over 2x. And that will be equals to 3. From there, if I've got a log and number on the other side, then the easier way to do it is to change it to exponential. So if I change it to exponential, I get x plus 36 all over 2x equals to 3 to the power of 2, which is going to be a 9. Okay, so I'll have a 9 there. So it's 3 to the power of that, so it will be a 9. So you don't say 3 times 2. It will be 3 to the power of 2. That will be a 9. So therefore I'll get x plus 36 equals to 18x. Then I'll have the 36 to the side, so I'll have negative 36. There I'll have a negative 17x. So I'll get x equals to 36 all over 17, and that is my final answer. So the biggest thing here is to understand your laws of exponents, laws of logs. Because if you don't understand the laws of logs, this question you'll never be able to do. Never be able to do. So which means I must understand that when I subtract, I write them like that. Okay, when I add, I multiply those brackets. I would have multiplied if that one was a plus. Okay. Now, exponents, this type of exponents here, without using a calculator, I know. Then you come here and then try to use a calculator, you won't get it right. Now, the first thing that you need to understand when we have a plus sign is that I am going to have a common factor, especially in exponents, which means I must first break this down. So if I break that down, I'll have 5 to the power 2n multiplied by 5 to the power of 1. I've got a plus sign. I'll have 4 multiplied by 5 to the power of 2n all over 5 to the power of 2n. Remember, 25 is 5 squared. So it's 5 squared. The 2 multiplied by the n is 5 to the power n. Then from there, I can see I've got a common factor here and there. So I'm going to say 5 to the power 2n into 5 plus 4, because I'm taking out 5 to the power n as a common factor. I'm dividing this by 5 to the power 2n. And that cancels, and that answer becomes 9. Easy as that. So meaning that what do you need to understand here is that I see it as a base 5 is a base 5. I see 25 can be base 5. Okay, so now after I've done that, because there's a plus sign in between here, I must take out the common factor, and then I can just cancel out. If there was no common plus sign in the middle, that form was not supposed to be there, because I would have taken the bases there, and then from there I can work with the bases. When I multiply, I add exponents. When I divide, I subtract the exponents, okay, of the powers. Right. So now the next activity that we're going to be doing is the binary number. You'll get one question in binary numbers. Then I'm not going to waste time with this question also in the binary numbers, because with binary numbers if you're using, I know mostly in your schools you use the sharp calculator, which is quite very easy to use in terms of your binary numbers, your complex numbers, and all that. So you can be able to use that. So obviously, I'm just going to explain what you need to do in this question, and then we move on. Now, with the binary numbers, remember, if I've got 23 there, I've got a decimal number and a binary number. Then I cannot add the two like that. So what do I need to do? Now, in this case here, the question here did not specify, but that question here was supposed to be, your answer should be in decimal form. So in decimal form means I need to change this one first and make it, I must change it to a decimal. So remember your table where you draw your table, or if you've got a calculator there, you are able to compute with a calculator, and you just go shift binary, and then from there you punch in the binary number 11001. Then after that, and then you just say shift decimal, and it gives you a decimal value. Then once you get a decimal value, you just add it to the decimal. Don't change this one and that one at the same time. Otherwise, you get this one to be binary and that one to be decimal, and you're back to the same thing. Okay, so remember, you have 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. Okay, so then you're able to check, this is a 1, this is a 2, this is a 4, this is 8, this is a 16, this is 32. So you add more here, you have 2 to the power 6, which is going to be 64. Then you can check then you have got a 1 here, then you've got a 0, then you've got a 0 there, then you've got a 1, you've got a 1 here. So I think that's the total there. So you're able to add those numbers, and then you're able to see what your values are. Okay, then you can add those numbers, and then from there you add it to the decimal form, and then you can get your final answer. Okay, all right. Or you can use a calculator, just change this one and then plus add it to that one, then you're going to have that. All right, now the other question that has a big problem is your nature of the roots, and I don't understand why, because this is quite very easy. And most of you skip this type of question. So please do not skip this question. They are quite very easy. If I'm given this and they say without solving the equation, so you just look at that, without solving, which means that if they say without solving, the only formula that I can use is b squared minus 4ac. Remember, this thing there is the discriminant. It is called delta, is the discriminant. It is the one that enables me to determine or prove or show that the roots are this. Okay, the roots, the nature of the roots. So in this case, they say without determining the nature of the roots. So the b, I substitute the very same way as I substitute in the quadratic formula. So it's going to be negative 2 squared minus 4 into 1 into 3. So there will be 4 minus 12. The answer is negative 3. So once I've got a negative 8, remember this b squared minus 4ac in your formula, it's inside the square root. Alright? So if it's inside the square root and you've got an answer which is a negative inside the square root, then my answer becomes non-real. We know you're doing complex numbers. Don't write your answer, it's minus 2 root 2i. No. We want the nature. What kind of roots are we going to have? We're going to have complex roots. We're going to have imaginary roots, or we're going to have non-real roots. Okay. I know when you want to be unique, you write complex roots. Right. So, but we know that will be complex roots anyway. In this case here, they say if the roots are non-real, you are given that the roots are non-real. So non-real means there's a negative inside the square root. If I got a 0, then the root will be equal. If I got a perfect square, the root will be rational. So go and practice those there in your notes. Go and practice them. In this case here, they say determine the numerical value of k for which the equation will have non-real roots. So meaning that your delta b squared minus 4ac, it's already given to you as less than 0, because non-real roots means less than 0. So these questions are basically more or less the same. So now I'm going to substitute. First, I must write this one in correctly. So the minus k must come this side and becomes a plus k. So the b will be 2 squared, sorry, the positive. My a is 1. My c is a positive k less than 0. So I'm solving for k in this case. So I'll have 4 minus 4k less than 0. So minus 4k is less than minus 4. And then if I divide both sides by negative 4, the answer is going to, the inequality changes to negative, to greater than. So for k, for any value of k which is greater than 1, then the roots of that will be non-real. Okay, and that's what it means. It means that if I substitute the value of k by maybe 4, the roots are going to be non-real. If I substitute by 2, the roots will be non-real. Okay, so that's what it means by that question. So determine the numerical value. So we need the numerical value. So it should be values. All right. Okay. Right. We are going to take a 2-minute break. Then we'll continue from there. Okay, welcome back. Let's continue. Now, the next part of the work there on algebra still. You see how much algebra we have in there. The algebra still, we have the complex numbers. Now, with complex numbers, one thing that you need to also first look at is how to add them, how to subtract, how to multiply them. The division is also very important because then it uses the conjugate. You remember that. Then you need to know the rectangular form of writing it. You need to know the real and the imaginary number on the rectangular form. You need to also write that as in polar form. Remember, starting with the modulus, the argument, you know, the 3 6 what. You've written that, you've done that also in your PET. Hope it's still fresh in your mind. Then you have the Argand diagram. You can be asked to represent that in the Argand diagram. And it's very important when you're given a complex number to first represent it and see in which quadrant you are working with. The solving of complex numbers with two unknowns. Remember, this is another kind of a simultaneous equation, and which we'll also look at just now. Okay, so here they say write down the conjugate of that. So remember, with the conjugate, what do? You change the sign of the imaginary, right? So now it means that I've got -1 plus 3i. So my conjugate, and I must know the sign, I must put a bar on top of the x, which indicates that there's a conjugate. I'm going to write -1 minus 3i. The -1 remain as it is. The 3i is the one that changes the sign. Okay, right. Now, determine the modulus. So you must also know the terminology, these terminologies to say which one is the modulus, which one, and now there it is written. The modulus is the r value, and the argument is the theta. So don't confuse the two. Okay. So how do I write the modulus? So I'm going to write r is equals to the square root of. Remember, it's a squared plus b squared. So I can take -1 squared plus 3 into square. Don't put the I inside the bracket because we're only looking for A and the B. So remember, we're looking for the A and the B without the I. Okay, so my R is going to be 1 squared is 1, 3 squared is 9. So my I is going to be the square root of 10. So mostly please just leave the answer in set form and don't try to put it in as a decimal. Okay, so just leave it like that. Now 1.3 says given the argument. So the argument, I need the angle. Now remember, the angle, the theta angle will be equals to the b over the a. Don't try to be smart and put a over b. Don't be correct. So my a over my b over a is going to be 3 over -1. So if I need the angle, first of all, I'm not going to get the angle, I'm going to get the reference angle. Why? It is because I'm working in the quadrant, in a quadrant where we have a negative. I'm going to show you what I'm talking about here. So I'm just going to make space here. So I'm going to first get the reference angle. Now, the reference angle, I'm going to say shift tan 3. I can say over 1, doesn't matter. 3 over 1. So the angle that I'm going to get is 71.57. This is not your final answer. Right. This is not your final answer. So if I draw my Argand diagram with an imaginary axis and the real axis. So my value of y, remember this b here is a y value. So my value of y, or my value of the of x, my value of x is going to be, this is x plus yi. So my value of y, which is imaginary, so my imaginary will be at 3, right? but my x value is at -1. So I'm going to have -3 and -1. So the point will be there. So my point here will be the value of x is -1, the value of y is 3, and remember it's 3i. So that is my x value and the y value. So I'm working in the second quadrant. So what do I know? In the second quadrant, I use the reduction formula, 180 degrees minus. So it is very important that you understand first which quadrant you are working with by using your Argand diagram. Then the Argand diagram will will help you in terms of identifying the quadrant that you want to work with. So I'm going to then say 180 degrees minus 71.57 degrees. And the answer that I'm going to get is 138.43. So that's my argument. So my argument is not this one. The reference angle is 71. Because now I'm working in that quadrant. My resultant is this one. The angle is that angle. So which is 138.43. Okay. Hope you get this right. Every time you see you need to find the argument, draw your Argand diagram, see where your quadrant is, and then write down the correct quadrant. Now, these questions also are very, very, very easy questions that you need to also know how to do them. First of all, if I then multiply out the brackets, I'll have -1 plus I equals to 4 plus 5i. The easy way to do this is, I'm not going to bring all the i's together and all that together. I'm just going to write it as it is. So I'm going to draw a line like that. So I'm going to say on my left hand side, I need to write the real part. So my real parts on my left hand side, it's x, it's -1, that's done. And my real part on my right hand side is 4. So I have a 4 as a real part, -1 this side, x this side. These are real parts. On the other side, I'm going to write the imaginary part without an I. So I'm going to look at this as y. I've got +1. There's a 1 here, so I'm going to write a 1. I'm not going to write an I on my left hand side. On my right hand side, it's only 5. I'm done. So my x value here will be equals to 5. Take the -1 that side, 5. My y value here will be 5 minus 1, which is 4. So I'll have my x value and my y value and x value, and done. Simple as that. So the only challenge is when you have a fraction on the right hand side or left hand side, where you need to do the conjugate thing, multiply by the conjugate, then divide it by the conjugate. Then from there you are able to can write it without a fraction. Then you are able to can do this method. So that this method is quite very easy to use, because then you just put your, if you find that you've got an x and a y on one side and you have your x and y on the other side, simultaneous equation. You see where simultaneous comes in. If you don't understand it in question 1.3 somewhere, then you won't be able to understand it here when you need to use the simultaneous equation, where you have an x and a y and an x and a y. Okay, so make sure that you understand simultaneous equation. Right. Done with algebra. So you can see that the algebra, there's a lot of work to be done in algebra. Once I get the algebra right and get up to 40 marks out of the algebra, I'd have done a very good job. Because once you have done with the algebra, then your other work that you're going to do will be much easier. The ones that I did not put here is the functions. I did not include the functions here. I really need to include the functions because of the time constraint. I just look at those topics that we need to get marks from. Now remember, in functions, we've got 4 functions. You need to understand how to multiply them. You need to understand how, you need to understand how to draw the sketches. You can use a table to draw those sketches. You must also know how to find the equations of those sketches. Those are the two main things that you need to understand. And also understand how to interpret those sketches. Okay, so because of time constraints, we just put some of the topics that we think, this easy marks that we need to get. But also in functions, there are easy marks that we need to get. Go and practice functions again. And then you get up to 20 marks or so up from functions. They're quite easy. If you understand your geometry well, I mean, functions will be quite easy to manipulate. Right. In differential calculus, this 3 marks or 4 marks, we must get this form. Everyone must get 4 marks. Why am I saying this? It is because this question, you already have an answer. In this case, the answer that you must get is 3. That's all that you're going to do. But now, because of it's the number that is next to x, it's always the number that is next to x. With technical maths, differential calculus, the answer is already there. Now it means, if I say first principle, it means that I must then use a formula. So the word first principle means that I must use a formula. I cannot just write down the answer. If you write down the answer only, you're going to get a 0. I'm telling you now. Now I'm going to write down the formula. The formula is there. It must be written properly. Make sure incorrect formula and notation, you'll be penalized. Because the formula is there in the formula sheet. Graphs are so easy. Why do we need to stress ourselves with these graphs that are so easy? The graphs has been scaffolded, meaning that they don't just give you a graph like this, given this. They don't just say this and they say sketch the graph. Sketch the graph. And from there they just say maybe 12 marks. That will be a big challenge for us. Because some of us I know challenge just to get the x and the y intercept. But if they just say sketch the graph 12 marks, that will be very difficult. So what is it that we need to look here to do? Is to make sure we understand the breakdown of what we are supposed to do until we draw the graph. Now, it's a 5-point plane. So when I talk of the 5-point plane, this is what I'm talking about. The first part of my plane will be to get the y-intercept of the graph, which you're going to be asked. Secondly, determine the x-intercept of the graph. Number three, determine the turning point of the graph. Number 4, shape of the graph. Number 5, sketching the graph. 5-point plane. So the 5-point plane, you must know that how do I get a y-intercept? How do I get the x-intercept? How do I get, so the process of getting those must be known. The first thing here, write down the y-intercept. What do I know about the y-intercept? I must know that the x value should be equal to 0. What do I know about the x-intercept? I must know that the y value must be equal to 0. And what do? I solve. Okay. How do I know? What do I do to get the turning point of the graph? I must derive and equate to 0. All right. I'll come to the shape. So once I know this, then I'm able to tackle my problem. Now, how do I tackle my problem? Now, I'll say, if I put a 0 there, 0 there, 0 there, I'm only left with the 5 that does not have an x. So which means my y-intercept, everybody must get this, will be equal to 5. But please, I want you to do that. You must put zeros there. And then if you need, use a calculator to see 0 cubed, and 3 times 0 squared, just like that, there's a 0. Okay, making sure. Right, number 2. How do I get the x-intercept of the graph? Now, with the x-intercepts, I've gone through a lot of technical maths question paper, mostly. I find that the equations that are given, for instance, here, if I use my calculator, I'll get 1 or 2 factors. I've worked out this one and I've got both factors. Now, but I know what your teachers have taught you, to say you must try values x equals to 1, x equals to -1, x equals to 2, x equals to -2. You get one factor, you use your synthetic method, and from there you can do whatever. But if you go to your calculator, and I just could put you through the process of getting into your calculator. So if I get to the calculator and go to table mode, and then get the equation in there, x cubed plus 3x squared minus 9x plus 5, and then I press equals to, and then you say start, and you'll start. I know most of you are doing it with me now. Then you're going to have it will say start. If it says gx, just press equal sign, then you say start, and then you start at, say, -5, then equal sign, and then say end at 5. Then from there it says step, and then you just say equal sign. Then you get a table. In a table that you got, at -5, there's a 0. Check that. At 1, there's a 0. So already this gives you an factors. How am I going to write down the factors? So this is how I'm going to write my factor. So I'm going to say my x plus 5 is one factor. My x minus 1 is one factor. Then I need the third factor. How am I going to get the third factor? Simple. This is x cubed, meaning that x times x, I need another x here. Then from there, how do I get the plus 5? I already have the plus 5 times minus 1 is going to be negative 5. For me to get a plus 5, I need to multiply this by negative 1. So therefore, these are my factors. Right? Now I'm solving for x. So I know in the calculator, that's exactly what you're going to get. If I get two factors, or if I get one factor, I can get the rest by using the synthetic method and other method. Long method, synthetic, or the trial and error method. Now in this case, I've got my x values. It's minus 5. My other x value is 1. My other x value is 1. So these two are the same. Alright? This is very, very, very important. If I've got these two being the same, it means that this is going to be the x-intercept, and it's also going to be the x value of the turning point or the stationary point. Okay, right. Remember, turning point, sometimes they call it the stationary point. So please note those two. In some question papers, they'll write stationary point. In some question papers, they'll write turning point. Okay, right. How do I get the coordinates of the turning point? So I'll get x derived. So I'll get 3x squared, I'm deriving now, plus 6x minus 9 equals to 0. Then if I divide throughout by 3, I'll get plus 2x minus 3 equals to 0. Factorize this is quite easy to factorize this. X minus 1. Then x will be equals to negative 3, or x will be equals to 1. Can you see that? X equals to 1 is it's an x-intercept, and it's also a turning point. Now the values of y, if I substitute, I've already substituted. I think I got a 32 there, and I got the other one, y value will be a 0. So I have my turning points here. So my turning points are going to be, I've got two of them, minus 3, 32. The other turning point will be 1 and 0. Okay, so I already have these two. I already have those two. I already have my y-intercept. The next thing that I need to look at is the shape. Now, how am I going to get the shape? How am I going to get the shape of this? So, for me to get the shape, I must know if this is a positive. I already know that I must have a cap and a cup. So my first turning point is a cap. My second turning point is a cup. Right? Right. So this is a cap. So if the A is less than 0, in other words, it's a negative, my first turning point will be a cup, and my second turning point will be a cap. Right? So if you know this, then you're sorted with this. So first of all, I need a negative 3. Well, I need a y-intercept. Let's say my y-intercept will be somewhere there at 5. Negative 5. My x-intercept is at 5. And my other intercept will be at 1. Okay. Now I'll have the y-intercept will be at 5, somewhere at 5. Then I need the turning points now. So my turning points will be at negative 3, somewhere there, and maybe 32 will be somewhere up there. Okay. Now my other turning point will be here. So can you see it's a y-intercept and so x-intercept and a y-intercept at the same time. So let's check the cap and the cup. The first turning point is a cap. So a cap looks like this. I draw a cap. The second turning point, I draw a cup. Then I just join my cap and my cup. So my cap. There. Then from there I join my cup up. That is my graph. Okay. So if your points do not allow you to do that, because sometimes you made a mistake somewhere on the cup and the cap, and your points does not allow you, what do? You draw the shape of that graph, and with luck you might get a mark for the shape. Okay, but you know the shape. Just that your points, sometimes you find that your points are not correct, but at least you know the shape of the graph. Okay, so make sure that you understand how to draw the shape of the graph by using a cap and a cup and a cup and a cap. Okay, right. But if your points, you see the points are not drawing that, go back, check where you made a mistake, and then address that mistake, and then from there you can see your graph has got a cap and a cup. Or you can use a table, substitute the values, and then from there you draw it, because you need that mark for the shape. Everybody needs the mark for the shape. Right, determine the values of x for which the graph is decreasing. So what does the word decreasing mean? It means that where is the graph from the turning point? You see this graph up here. Remember, we read graphs from the left to the right. So from the left, the graph is increasing, going up, 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 up. So increasing, 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 increasing. But once it is there, it's stationary. Can you see? There it's stationary. That's why we call it a stationary point. What does it do from here? It starts decreasing. But then it goes to the stationary point. From the stationary point, what does it do? It starts increasing. Can you see? So between which values, remember this we said is -3. Between which the values is the graph decreasing. So you can see the graph start decreasing after -3, and it stopped decreasing before 1. So you just write the values. X is less than 1 and it's greater than -3. So it is between -3 and 1. That's why the graph is decreasing. Where is the graph increasing? From -3 to my left, from 1 to my right, the graph is increasing. Okay, these questions are quite easy. You must always get it right. Don't write equal sign, because once we write equal sign, it means that the graph is increasing at a stationary point, which doesn't make sense. Okay. All right. Okay. The last but one topic, the integration. I'm not going to go through the rules of that integration. Already you all know you need to go and study those rules. Determine the following integrals. First of all, before I integrate, I must then write it properly. So I'll have x cubed plus 6x squared dx. You see, I have not yet integrated. So for me to integrate, what do I write? I write equal sign, and I no longer write that sign for integration. So if I integrate this, it gives me x to the power of 4. Remember, it's plus 1. Plus 1. Then you take the n plus 1 down. So it's 3 plus 1 is 4. This 4 must go to the denominator. Then from there we say plus the 6 and the 2. The 6 and the 2, what do? We add a 1 plus on the 2, it's a 3. So it's going to be a 6x to the power of 3. We divide this one by 3. But I can simplify this. So it's x to the power of 4 over 4 plus the 3 there goes 2 times in there. So I'll get 2x to the power of 3. Then remember, we must write c because there is a constant for that integration. As long as if it's not a definite integral, it will have a constant, which is plus c. Number 2 is the same principle that we're going to use. First, before we integrate, we must write this properly. X to the power 1 over 2 is a half, plus 7 over x. Don't integrate per term, please. Then plus 4x to the power. You see, I'm keeping it as it is. You see, because I've not yet integrated. So when I integrate, is then that I put an equal sign with that sign. So it's x to the power 3 over 2. That 3 over 2 will be again at the bottom. Remember, the integration of 7 over x is the same as 7 multiplied by 1 over x. So which is going to be 7 ln of x. Plus. Or it will be yes, it will be a plus. But now, remember this one we're going to add a 1. So if I add a 1, I get 4x to the power minus 4 all over minus 4. But then I need to simplify this, write it correctly. I cannot write a fraction value over a fraction, so I can write this 3x to the power 3 over 2 all over 2 plus 7 ln of x. Then the 4 and the 4 cancels out, so I'll have a minus x to the power of negative 4. Don't forget it's plus c, like the constant. Okay, right. Interesting one on the third one. There I can immediately integrate. Okay, so for instance, that one, remember, I'll have 3 ln of x. Then I'll have the ln of x. Then I'll have plus c. So I can just integrate. Remember the differentiation of, the integration of that one will be the ln of x also. Okay, right. Okay. The next question is one of the questions that comes every question paper, and now we try to change it a bit there and there, but still is the same principle that you are using. The process is the same. So in this case here, they just want you to get the value of a. This thing is not correct. It's not to the correct scale. Okay, right. We just trying to get the value of a there. Okay, so we're saying the graph is g of x is 3 is x cubed. So which means that we need to integrate the x cubed between the a value and 1. Right, remember the maximum should be on top, the minimum at the bottom. Right, so now from there, what do I do? Integrate this. To integrate this, what am I going to get? So remember, when I integrate, I'm going to put this in the square bracket so that I put the a and the 1. So remember, this is given as 15 over 4. Why? It is because 3,75, it's 15 over 4. So if I work that one out as a fraction. So meaning that the answer that I must get there, the area is given as 15 over 4. What am I looking for? I'm looking for the value of a. So there, when I integrate, I'm going to get x to the power of 4 over 4. All right. So now I'm going to then substitute. So I'm going to substitute this. Don't put this bracket. Don't put this bracket because we've got double brackets there. I'm going to substitute. So I'm going to say a to the power of 4 over 4. I'm substituting by a first. Minus a 1 to the power of 4 over 4. That gives me 15 over 4. All right. So I'm going to then, what do I do then? Then I see I've got a 4 and a 4 and a 4. I can multiply throughout by 4. So multiplying throughout by 4 gives me a to the power of 4 minus 1 equals to 15. Then I get a to the power of 4 equals to 16. How do I get the value of a? No, 16 is 2 to the power of 4, a to the power of 4. Times 1 over 4 times 1 over 4 to eliminate the 4. So I'll get a equals to, this cancels out, will be 2. So my value of A there will be 2. So it will be between 2 and 1. That's where I'm going to get the two values. That's why I'm going to get the A value there. Okay. Alright. That question, it comes every year. Let's get this question right. Let's get this question right. The area is given, then get the other value. If the area is not given, the two values will be given. Work them out, subtract. Remember the maximum on top, the minimum at the bottom, so that then you don't have a situation where you get negative values. Okay. Right. That's the last question here that I'm going to do. So the last explanation that I'm going to do in terms of finance. I'm not going to do questions on finance. What you need to know under finance is just the keywords that are there in those questions. What does a simple interest mean? It means you're going to the weighting. The keywords that are going to get there. It's straight line basis. If they say straight line basis, use simple interest. If they say linear basis, use simple interest. Higher purchase, use simple interest. So these are the keywords that you need to understand in financial math. Compound angles, you find this: exponential, inflation, population growth, reducing balance. Reducing balance. So once they say reducing balance, what do you know? The formula there will be a negative. Okay. So if you look at that formula there is a reducing balance. Okay. Population growth, there's the formula. Okay. Inflation, there's the formula. Exponential, you see, there's an exponent that we're talking about. Okay. They say something is growing exponentially or is being reduced exponentially. So you check the keywords then. This is simple interest. Okay. Compound interest. This formula for effective is there in the formula sheet. Please go and learn questions on that. Okay. Remember, if you're using the n, if you're looking for the value of n, then you're going to use the logs. Okay. If they say calculate the n, then you use the logs. The depreciation, decay, all those values, decreased, reduced, those are the formula that we're going to use for that. For appreciation, the growth, increase, and that, these are the formula that we're going to use for that. Okay. Right. Lastly, here's the periods of compounding. Annually, you must know it's just divided by 1. Annual. If I say semi-annually, that's divided by 2 and multiplied by 2. Quarterly, we have got 4 quarters in a year, like seasons. Then we multiply that by 4. Monthly, we've got 12 months in a year, so you multiply that by 12, divide that by 12. 52 weeks, you divide by 52, you multiply n by 52. Daily, divide by 365 and multiply by 365. Just want to quickly show you that question there. Calculate how long. So how long means the value of what? The value of n. I'm not going to do this question. Just want to show you that. And they say the car battery measuring 12 volts to lose its charge to 4 volts. So meaning that there is a depreciation. You see, there's a depreciation. So if there's a depreciation, it means that we're going to use the formula with a minus. Okay, right? So 5% of its initial charge per day. You see, it's using it 5% per day. So it means that the interest will be divided by 365. The number of years will be multiplied by that. So in other words, this question was supposed to say 5% per annum of its initial charge per day. So that then we know it's per annum, but it's losing it per day. So we'll have the 365 days. Okay. So lastly, just want to wish you good luck in your paper tomorrow. Let's go out there and really work very hard and practice. Let's practice tonight. And then let's make sure that we understand each and every concept that we have done today. And good luck for your exams, for paper 1 tomorrow. Then we'll see each other tomorrow in preparation to paper 2. Thank you so much.